All right, so we did sine and cosine, and then cosecant and secant. And so if you can do sine and cosine, cosecant and secant should just follow pretty easily. And then the next ones that we have are tangent and cotangent. So we'll start with tangent of x. So tangent functions don't have an amplitude, unlike all the other ones. But they still go out to 2 pi. And I'm going to go to probably out pretty far on both sides. So pi over 2, pi, 3 pi over 2, 2 pi, and then negative pi over 2, and negative pi. I'll do to negative 3 pi over 2 like we did on the last one. So where on our unit circle is tangent undefined?
It's at the top and bottom.
Yep, so at pi over 2 and at 3 pi over 2. So at every odd increment of pi over 2, so pi over 2, 3 pi over 2, 5 pi over 2, so on and so forth, we're going to have an asymptote just like we did up here. Oh, turning away. So this one, the asymptotes are actually in the exact same place as they are with secant. So at pi over 2, 3 pi over 2, negative pi over 2, and negative 3 pi over 2 on this one that I've drawn so far. So my tangent function looks totally different than the other ones. It starts down here. It's going to kind of look like a cubing function. It starts down here. It comes up and through the origin. And that's like your baseline one. But it repeats over and over again. So just like how sine and cosine, like they're just a continuous like wave, these ones do the same thing in every spot. So, about to mess this one up. So I'm coming up and I'm going through pi and up. If I go over here in this one, coming up through negative pi, and I'm never actually crossing my asymptote, just getting really close to it, and it just keeps going up. Then we have cotangent. Set that one up similarly. So same increments here, pi over 2, pi, 3 pi over 2, and 2 pi. And in this case, I'm going to actually go all the way back to, well, I'll just go to negative pi. I don't have room to go all the way back. So cotangent has asymptotes where tangent is equal to 0 because cotangent is 1 over tangent. So if the tangent is 0, then that's going to cause cotangent to be undefined. So where is tangent 0 on our unit circle?
Sides.
Yep, the two sides. So that's at increments of basically 0 and pi, so even multiples of pi. So my asymptotes are here on the y-axis at 0. It's hard to see that one. And then at increments of pi. And then cotangent is just tangent flipped, so it's going to start high and come low. Focus it for a second. So we start up here, and it comes down this way. And it's cutting through that middle value, so at like pi over 2, it's to where it's cutting through. So if I'm asking you to graph like the parent functions of these, this would be totally sufficient, just having these three here. Anytime we're doing our graphs, we want to make sure we have our labels on there, especially on that x-axis. And then as far as everything else, we just want to make sure, like, if there's asymptotes, we've got to put those. That's something that in my other classes they've been forgetting. They'll, like, graph them, and they'll, like, show that they know that they're there by how they graph it, but they don't actually put the dotted lines there. So we want to make sure we do that for all of the ones that have asymptotes. And then on the ones that need an amplitude, like sine and cosine, we want to make sure that we are putting those as well. When we have our parent functions quiz, it would be totally fine for you to do sine and cosine, let me back up. It would be totally fine for you to do sine here like this, and then also put cosecant on that graph, just label which one's which. Okay, so how I like pointed that this is sine, and then cosecant is the other one, I like circled it in red to show that. And then down here, I didn't actually write this in, but this was cosine, and so then secant is coming off of it, and so I'll just do that to show that that's what I did. Anyways, that would be totally fine, so that you're not having to do like 4 separate graphs, since you need sine and cosine in order to be able to graph cosecant and secant. So I started letting them do that this year, and it was just way easier and less graphs for me to do. Less room for error, less room? I don't know. Anyways, there was less error happening because it wasn't like you were graphing sine and cosine, then having to come down there and graph them again to graph secant and cosecant. So you can just put them all in the same graph. But I like for us to see them separate first before, And like I said, if you are going to do them all separate, if you're like, I just think it looks nicer to do them separate, that's fine. All you have to have is like one full cycle in blue. What I have in blue is one full cycle. I just extended it in red so we could see what was happening. Any questions about parent functions? Anything? All right, I'm going to stop this.